Great. Good morning. Thank you for attending this session. For this audience, we don't have to convince you that informational text can be found everywhere across the web. On public domains, you can find news article, blog posts, discussion board of all sorts. Also in private communication, there are text messages, email messages, internal reports, and such. So the nice thing about working with text is that it can be readily found and used. The challenge for text analytics is to do more than just NLP syntactic parsing and to extract semantic content from it. And that's what we're going to talk about today. Okay. So in this talk, we'll demonstrate in two ways the text analytics. The first is that we want to show you how to take any free-form text, whether it's long, short, of any kind, and extract meaningful semantic content to produce structured data so that you can then use for further analysis for data mining or machine learning applications. The second part of this, the second thing about this text analytics is that we want to do it in a way where machines can call these services and the results formatted in JSON can be interpreted by machines. Really, there's no human interaction in the whole pipeline of this. And Ronald will actually show you a text analytics pipeline that we built from scratch, and we'll show you the entire pipeline step by step, starting from URLs that you can extract for news, for example, and taking it all the way to produce semantic content and then visualize the results. Okay. So the text analytics API that we are using is from the Data Ninja family of services. There are actually 4 sets of services. The one I'm talking about today is focused mainly on one, the smart content, which basically extracts any free-form text to produce some sort of structured data. And I'll go through what that structured data is. These services are RESTful API, and they can be accessed on the cloud from anywhere. The API is relatively simple to use, but underneath all this is a pretty impressive knowledge base that we keep it up to date on a daily basis. So new concepts and new categories are being added on a daily basis. And we want to do it in a scalable way through the power of cloud computing and big data so that we can do this with ease. So the structured data that we are returning includes the following. And when Ronald goes through this in the JSON format, you'll see that there's actually a lot more. I'm just giving you sort of the simplified view of them. The 4 main types that we are returning are concepts, categories, entities, and keywords. For the first 2, it basically characterizes some of the ideas and generalizations from the text. The last 2 are more specifically to certain entity that we can extract, keyword, and so forth. And we also return sentiment as well, and you'll see an example of this. I think the best way to show text analytics is to give you an example. So what I have done is taken an excerpt of a news article, and the news article is quite long. I just took like a paragraph from it. And you'll see that it talks about the Zika virus outbreak. And you notice that none of the texts mention the Zika virus explicitly. But what we can then do is to call the Data Ninja services. We can then extract that the concepts include things like the Zika virus outbreak, the microcephaly, Zika fever. And we actually return many, many more. I'm just showing here the top 3. We also return the categories from them. And the categories can be at different level, from something very specific to something very general. They are specific in flavivirus all the way to diseases and disorders, and then health is much, much more general. So depending on your use case, you might be interested in something more specific or something more general. Entities are different from concepts in that concept can be discovered even though it's not mentioned explicitly. For entity, it has to be mentioned explicitly in the text. But it doesn't have to be spelled in the same way or capitalized in the same way. So here we can identify that Brazil and the World Health Organization are two entities. And then sometimes related to that are people find keywords are also useful. There's some overlap between entities and keywords. I'm not showing the overlap pieces, but it can also return those entities in the keywords. And sometimes keywords might be more interesting because it can detect things like mosquito-borne virus as something that is of interest to you or birth defect. So all of these things can be run through the Smart Content service using the Data Ninja API. And you can check it out at dataninja.net. Okay. So Data Ninja API is more of a service. What we want to do is to take that service and build something more like an app where you start from beginning to end. We use this, show this use case to kind of illustrate how you can use these text analytic services. So we start with news aggregator, and we use for and produce text from them, extract the text, and then feed each of these article texts through the Data Ninja services to produce the structured data that I was mentioning. And then from there, we use machine learning to detect the topic clustering and identification. And then we have actually a visualization through an app. We call this app the Newsbot Ninja, and you can check that out there at newsbot.dataninja.net. And I'll have all of the URL at the end as well. Okay, so Ronald, you can do the...
Thank you, Trung. So let me get my Jupyter notebook up here. Okay. So what we want to do in this demo is to follow up in terms of what Trung described, the data services, the different APIs, and the output, the rich semantic content that we can extract from text, and go ahead and build a text analytics pipeline from scratch. And we're going to do this live. So the idea would be to build something similar to the Newsbot Ninja service that Trung mentioned, whereby we're actually going to go to Google News, the current Google News page, and fetch the page, extract the URLs, do some cleaning to find actual news URLs, URLs that are pointing to news articles. Then we're going to show how you would go ahead and integrate the Data Ninja service into a text analytics pipeline. We will run that for some small number of URLs out of what we could collect here. And then we will do some interesting machine learning with it. We'll try and run through some clustering with it. The whole thing is going to be live with actual data that's currently available here. So let's get started with that. So the first thing we want to do is obviously do some pre-processing, right? So in our case, most of you, I'm assuming, are Python developers or you're familiar with Python. So we're going to use the Python's Beautiful Soup library, which does an excellent job of fetching a URL and then allows you to declaratively find interesting markups in that HTML. So in our case, we're just going to pull all the links out of that HTML page. Once we have that, we will go ahead and collect the URLs. We do want to filter out some noise. So we don't want, for example, links that are pointing back to YouTube videos or Wikipedia pages or advertisements within URLs. So we want to clean up some of those things. But once we do this, it looks like we've got links that are more or less pointing to currently trending news articles. So after some filtering, we get usually around 200 or so links. Let's see what we get here. Yes, so we've got that many links. Once we have this, the next step in the pipeline is to go ahead and integrate the Data Ninja service. As Trung mentioned, we are using Mashup, which is an API hosting service for hosting our API. We've recently started to use the Amazon API Gateway as well, so you have a choice. The Amazon API Gateway might be easier because you might already have a developer account and you can simply use that to sign up for our services. Once you sign up, you will get a key. there is a free tier that you can start using. And then you'll just simply input your key, pass it as part of the header. And all of our services follow fairly standard REST protocols. So the one that I'm going to demo here is our smart content service. The smart content service, the payload is simply the URL. There are additional parameters that you can pass, and you can check that from the documentation, but essentially you will pass in a link, and the Data Ninja service will do all the heavy lifting at the back end. As Trung mentioned, we built our own knowledge graph, and we update it on a daily basis, so we use that to extract the categories and concepts and keywords and sentiments and so on. So we can take a look at what it looks like for a single URL before we go ahead and collect the information for the 100 odd URLs that we've collected. I'll come back to this. I just want to go ahead and start this process very quickly, and then we'll come back to that. Okay, so you saw on Trunk's PowerPoint slide the different things that we return when you call the Data Ninja service, especially the smart content service. And here's the actual raw output in JSON format, right? So, so this particular article is about a Warriors playoff schedule. And what we have done is to go ahead and, first of all, extract the text from that web page. And let me show that first. So here's the actual article text that we've extracted from that page. So one of the internal services that we call in the process of generating your output is to take the URL and apply our own machine learning techniques to eliminate all the boilerplate content from the web page and just extract only the text that we think is really the representative content from that web page. So you can see, right, so we've extracted including the actual schedule that's more or less in the format that it appears on the web page. That information then gets fed into the actual engine that does all the extraction of the categories. So you see there's some number of categories that identify or tag what's the content on that page. We have some number of keywords. I'm just going through, so keywords have sentiments. And then you see there's a lot of content here. Then we have concepts. So these are the concepts that we've identified from that page, along with the extracted text. So we give you all this information as a JSON response. And so you can very easily use this information to do all kinds of interesting work with it, right? So one quick example that we wanted to demo here is that, remember earlier on we went to the Google News web page and collected all the URLs and we've cleaned it up, and then we also did some further cleaning here. We want to have pages that have at least 100 characters in them because we want to do some clustering with this data. So that reduces the number somewhat, but we'll work with this number of articles. So what we want to do now is to sort of try out doing some clustering. So LDA is a popular clustering algorithm that people use. So we'll use the version that comes with GenSim. So the first thing we will need for that is to prepare our environment. So the first thing we will do is to create our stop word list so that we can eliminate them from the clustering step. And then here's a helper method for us to be able to do that. So first we will go ahead and tokenize the text, remove stop words, and then convert it into a vectorized form that LDA requires. And then we will actually call the routine to do the clustering. And then we will do some post-processing to produce output in a way that we can display on the screen. So we'll go ahead and run that. And once we've done that, we can actually call the routine to do the clustering. So we'll run that too. It takes a few seconds for us to finish that. This is all live. This is the current page as you would look at Google News right now. Nothing is canned about this particular demo. So let's see what we have here. This is a very interesting cluster. As you guys probably know, this is a trending news about one of the girls who was kidnapped from Nigeria being released. So that looks like a really good cluster. Usually there's a cluster about Microsoft making an announcement about their mobile operating system. Obviously, you get some clusters that related to the presidential elections. So you can see, as you can notice, I've clustered for 20. We can maybe reduce that number, increase that number, so you can play with that. But the idea is that, in a space of about 10, 15 minutes, we've actually built something start to end, and letting Data Ninja do the heavy lifting along the way. And even though, this demo is about using web pages and news articles, which are easy to get at, but you might have legal documents or design documents or healthcare documents. Any of those documents can be easily used with Data Ninja services to produce the semantic content that you need, and then do other kinds of machine learning and post-processing that you can do with that text information. Now, we have obviously built a much more complex pipeline, as Trung mentioned, which we'll be releasing soon, the Newsbot Ninja service, that uses some of these ideas, but we leverage the rich content that Data Ninja provides to build out our service. So with that, I'll pass it back to Trung to finish up.
Okay. So basically, we talked about text analytics, and as I mentioned before, text can be found anywhere, and it's hard to use them directly. So we want to provide a way to convert them into some kind of structured data that you can do further analysis on. And Data Ninja services allow you to do that. But if you want to do much more than that, with a particular use case, we illustrate one particular one called Newsbot Ninja. You can check it out at newsbotninja.api, dataninja.net. You can get the key to these API relatively quickly, so I urge you to try it out. And yeah.
What is Newsbot?
Newsbot is what we just showed with that use case, yes. It's in beta, so you can try it out and see the kind of trending news, cluster and particular topics, track different sentiment, different entities, different categories from that application. Okay, I think that's it. Thank you. Yes.
So you talked about concepts, right? You do concept extraction, but
Yes.
what if you're a business where you have a certain set of concepts that are quite unique to you? Is there a flexibility for that business to create its own models so that you can run it on that API so that you get better results?
Yes, so I mean, this is true. Oh, okay. Yes, the question, actually, you get a free t-shirt with that as well to encourage more questions. The question is whether you can get some kind of customization. Let's say if you're for a particular domain and you're interested in certain vocabulary and you want to supply that. And the answer is yes. We do it in two different ways. One is that you can provide us with a custom dictionary of things that you're interested in, or even things that are not even public domain, or particular kind of vocabulary that has another meaning or so forth. So we actually also provide API that you can do this programmatically and update us on a daily basis if needed. And we'll start extracting using those vocabulary for you. So that's more the entity extraction side. There's also the concepts and categories side that we can also provide and return specific categories, because the categories and concept that we have is millions of concepts and category, and for some people that's too many, and they want only 500 categories that they are interested in. We can also customize that for you as well.
Thank
Yes. Yeah.
What data sets do you use for concepts and categories? How do you decide what your concept and categories are? There must be like a
Yes, yes. So I mean, the knowledge base is the main thing, and we try to scrape as many publicly as well as use some proprietary data set to help us get as big a knowledge base as. And this is done on a continual basis. Yeah, I can't go into detail on which specific one, but we can talk afterward. Yeah.
What kind of
Yes.
ML
Right.
algorithms you use here?
Okay, you'll see.
What kind of ML algorithms you are using here? There are so many ML algorithms, but for concept extraction or entity extraction, what algorithm you use?
What algorithm do we use? Well, I can't go into too much detail about that, but I think the main thing for us is to see, what I would recommend you is to try out we have a demo that you can try it out.
I saw your booth actually.
Okay, okay.
That is but I'm interested more in the technical side actually, how
Yes.
what algorithm is best suited for this kind of entity extraction.
Right, and so I think there's a bigger conversation to be there. We can maybe take it offline, talk about that.
Maybe
Yeah.
I can just quickly interject and
Yeah.
say, so, when you build a complex pipeline like this, really you don't use a single algorithm.
Correct.
So pretty much anything that you find in a natural language processing machine learning textbook, we use them somewhere, right? So we use
Yeah.
SVM, neural nets, Bayesian models. So we use many different algorithms, graph algorithms, based on where that algorithm particularly does its job for us. So we have
Yeah.
fairly complex pipelines that do a lot of the back-end heavy lifting that runs on a regular basis to update our knowledge graph. So most of the results that you see is driven by the knowledge graph, and so the update process runs on a frequent basis.
So knowledge graph is a graph database, or what is the data store for knowledge graph?
So we've largely developed our proprietary storage mechanism. So there is a serving part. So that's served from a regular database. But in terms of what we do at the back end, obviously we use our own big data technologies like Hadoop and Spark and whatnot, where it makes sense to process through the volumes that we need to deal with.
Yes, there was a question over here. Any other questions?
I just want to also quickly mention the notebook
Oh,
is
yes.
actually hosted on GitHub. So feel free to go ahead and download that, modify. It's totally self-contained, everything runs. The only thing that you need to get is a key, either from Amazon or Meshape. If you can go and get the free developer key, then you can play with it. You can modify it and you can try out how the system fits for your specific needs, specific
Right.
use cases.
And we also have a booth.
Fully for English
Yes.
users.
Right now,
Yes.
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 The support list that you have is custom at a view. That is something that is custom implemented by you guys, right? Is it a manually created support list?
So this example is just to show how you use a standard LDA. We actually don't use the standard LDA. We've developed our own clustering algorithm. And so we do something different.
And also, I just want to mention that we have a booth upstairs, so check it out if you have time. Thank you.